In the last two videos, we introduced the ideas of significant figures and how to calculate answers considering the number of significant figures there should be. Although that still holds true, we need to consider another factor that may affect how we view measurements in chemistry. More often than not, when measuring something, whether it's the length, volume, or even energy, we get super small or large numbers. For instance, I wanted to be super precise when measuring the mass of my dog, so I used grams. After measuring and rounding a little, I got 13,600 grams. If I wanted to use this measurement for other things, it may be annoying or uncomfortable to keep rewriting it. Therefore, to solve this issue, scientists developed scientific notation. In scientific notation, we display numbers as a decimal, with only one digit in front of the decimal value, and the decimal multiplied by an exponent of 10. If we multiply by a positive exponent, we increase the number by moving the decimal to the right for every exponent. If we multiply by a negative exponent, we decrease the number by moving the decimal point to the left for every exponent. Let's try this by putting my dog into scientific notation. 13,600 grams should become the decimal 1.36, since we only want one digit in front of the decimal point. But what do we multiply? The number obviously must become greater, so I know I must multiply by a positive exponent. I need to move my decimal point to the right 4 times, so I need to multiply 1.36 by 10 to the power of positive 4. Let's practice this concept one more time together. This is my dog's favorite toy. I somehow measured the toy in kilometers and found that it is 0.0001524 kilometers long. Clearly, this is a really weird number to work with. Let's turn it into scientific notation. My decimal value should be 1.524, since we want one digit in front of the decimal point. Since we need to make this number smaller, we need to multiply by a negative exponent. I need to move my decimal point to the left 4 times. So I should be multiplying 1.524 by 10 to the power of negative 4. There's one really cool thing about scientific notation I want to mention. How many significant figures did my dog measurement have? If you watched the previous video, you should get 3. Notice that when we put the measurements into scientific notation, we end up with 3 digits. How many significant figures did my toy measurement have? You should get 4. Notice that, again, the measurement in scientific notation has 4 digits. When converting to scientific notation, you must make sure that your decimal value has the same number of significant figures as the original number. If given scientific notation, you can assume your final answer will have the same number of significant figures as the original number. Let's practice converting to scientific notation with the following 4 examples. Pause the video to try them out. I hope you've taken some time to solve the problems. 5,000 in scientific notation should be 5 times 10 to the power of 3. Notice that when we write 5 and not 5.0, since our answer should only have one significant figures. 4,560 in scientific notation should be 4.56 times 10 to the power of 3. 0.9410 in scientific notation should be 9.410 times 10 to the power of negative 1. 0.000000456 in scientific notation should be 4.56 times 10 to the power of negative 7. Let's try going the other way around, converting from scientific notation to standard form. Pause the video to try them out. 4 times 10 to the power of 3 in standard form should be 4,000. 14.3 times 10 to the power of 2 should be 1,430. 3.2 times 10 to the power of negative 2 should be 0.032. 7.03 times 10 to the power of negative 4 should be 0.000703. Scientific notation isn't just awesome for looking at numbers, but it's also really awesome for working with numbers. If I gave you these really super small numbers and asked you to either multiply or divide, you probably won't have a good time doing so. Scientific notation provides a really awesome way to solve a problem like this. So first, we need to convert these two numbers to scientific notation. This number, with a lot of decimal points, converted to scientific notation is 4.56 times 10 to the power of negative 7. This number, converted to scientific notation, is 1.14 times 10 to the power of negative 5. Let's display the division of these numbers as a fraction. As a fraction, according to some algebra rules you should be familiar with by now, we can split this fraction up into 2 different fractions, one dividing the decimals and 1 dividing the exponents. 4.56 divided by 1.14 equals 4. 10 to the power of negative 7 divided by 10 to the power of negative 5 can be solved using law of exponents. When we divide exponents of the same base, we can subtract the powers. Negative 7 minus negative 5 is negative 2. Therefore, our answer can be combined back into scientific notation as 4 times 10 to the power of negative 2. You can follow a similar concept when multiplying. We can split up the numbers to separately multiply the decimals and then the exponents. This time, we add the powers. Addition and subtraction are a little trickier. Fortunately, you're allowed to use a scientific calculator on your test, which can do all the arithmetic for you: multiplication, division, addition, and subtraction. Make sure to group your scientific notations into parentheses so as to not confuse the order of operations. Using a calculator or by hand, take a shot at solving the problems below. Pause the video to try them out. Before discussing the answers, notice that your calculator might display your answers in standard notation. If asked to display your answer in scientific notation, make sure to do so. Additionally, make sure to conserve all of your significant figures. If you're unfamiliar with how to do so, check out the previous video. The first problem's answer should be 5,000 in standard form, or 4 times 10 to the power of 3 in scientific notation. The second problem's answer should be 3,000, or 3 times 10 to the power of 3. The third problem's answer should be 6 million, or 6 times 10 to the power of 6. The last problem's answer should just be 3. This concludes everything you should know about scientific notation in order to progress through the course. As usual, practice is everything, so make sure to check the description below for free worksheets and answer keys for these concepts. See you guys in the next video.